Here we have a definite integral. It doesn't involve a square root, but we have our 1 plus x squared inside of something. So trig substitution is actually going to work for this one as well. Let's see how we'll do it then. We're going to make our right triangle. We want to set it up so that one of the sides will be this 1 plus x squared. Actually, we'll have it with the square root. That'll be okay. Let's show you how that works. So this one's going to be x, this one's going to be 1, this will be theta, so this will be the square root of 1 plus x squared. If we want to look at the trig function that connects these easier sides, then it's going to be tangent theta, and that's going to be x over 1. So x is tangent theta. That means dx is going to be secant squared theta d theta. Let's go ahead then and make our substitution. Now, something that's different here, when we do a change of variables with a definite integral, we need to do one of two things. We can either go off to the side and do an indefinite integral and then resubstitute, change our variables back to get it in terms of x, and then evaluate from 0 to 1. Or we can change our limits of integration and evaluate it while we have it in terms of theta. I think that's what I'm going to do here. So I'm going to change my limits of integration. If x is 0, we have tangent theta is 0. And when is tangent theta 0 on our restricted interval? Well, that would be at 0. And then our upper limit is 1. When is the tangent 1 on that restricted interval? That's going to be at pi over 4. So we're changing our limits of integration. I now have dx, which was secant squared theta d theta, and that's over 1 plus x squared, so that's going to be tangent squared theta, and then that needs to be squared. Now as we look to see what we could do with this, I could replace the 1 plus tangent squared theta with secant squared theta, and then this secant squared theta will get rid of one of these, so what I have is the integral from 0 to pi over 4 of 1 over secant squared theta d theta. But wait a minute, secant is a reciprocal function of cosine, so 1 over secant squared is just cosine squared. So this is the integral from 0 to pi over 4 of cosine squared theta d theta. And we know how to deal with that. We can use a half angle formula. So let's do that. So we will have the integral from 0 to pi over 4 of 1/2 1 plus cosine 2 theta d theta. We can now go ahead and perform the integration then, and that looks like that will be 1/2 theta and then plus 1/4 sine 2 theta, and that needs to be evaluated from 0 to pi over 4. So now if we evaluate this, we will have 1/2 times putting in pi over 4, that's going to be pi over 8, plus putting pi over 4 in here and multiplying this by 2 would be, we'd have the sine of pi over 2, which is 1, multiplied by the 1/4, so this would be plus 1/4. And then as we evaluate the lower limit, we would have 0, and the sine of 0 is also 0. So this is our answer.